So I am opening the first page now. This is the first problem I asked yesterday. Opening the page, I am sharing it now. So this is about perimeter of a regular polygon inscribed in a circle. The problem is P is the perimeter of a regular polygon of n sides inscribed in a circle with circumference C. C minus P is least among the following options for n equal to. So when we say C minus P is least, means it is to be decreased. That means the difference between the circumference of the circle and the perimeter of the polygon inside it inscribed in the circle, the difference in these two should decrease. Means perimeter of the polygon should come nearer to the circumference in value. If we observe a regular polygon of 3 sides, this is just an equilateral triangle. Suppose it is named as A, B, C. And if we take the side AB, this is less than the arc AB. Side BC, straight distance BC, is less than this curved distance, that is arc BC. And similarly, CA straight distance is less than the arc CA. If we add these three, AB plus BC plus CA becomes the perimeter of this triangle, which is less than, when we add the arcs, that becomes the circumference of the circle. Now we come to this second figure. In this figure, we have made this regular polygon of 6 sides using the previous triangle. How? If the triangle was ABC, I have taken the middle point of arc AB as P, middle point of the arc BC as Q, and middle point of the arc CA as R. If you observe the triangle APB, in this AP plus PB is greater than AB because the sum of the two sides of a triangle is greater than the third side. So third side is less than AB plus PB. But AP is less than the arc AP and PB is less than the arc PB. So you can say that AB is less than this total arc. AB is there less already, but AP plus PB is less than arc AB. But this AP plus PB is more than AB. So similarly, if we have added these two sides of the regular hexagon, that is the polygon of 6 sides, we have got a sum which is more than AB but still less than the arc AB. Similarly, the sum of these two sides is more than this side BC, but is less than the arc BC. And the sum of these two sides will be more than this side CA, but less than the arc CA. And if we will add all the sides of this regular hexagon, that means AP plus PB plus BQ plus QC plus CR plus RA. This will be more than the perimeter of the triangle, but still less than the circumference of the circle. So I hope this is clear.
Sorry.
Yes. Then we proceed to the last diagram. In this diagram, again we have the triangle ABC. We have the hexagon ABB QCRA. And we have further made parts of this arc AP, like suppose S point here, this is point T, this is point U, this is V, this is W, this is X. So we have got how many sides? See PD1, PB2, this way 4, these 6, 8, and 10, and 12. So we have 12-sided polygon now. So 12-sided polygon will have perimeter more than the perimeter of the regular hexagon because of the same reasoning, because two sides of the polygon of 12 sides, if we add, that is more than one side of the regular hexagon. So if we add this way 12 sides of the regular polygon of 12 sides, this thing is more than the perimeter of the hexagon, but still this will be less than the circumference of the circle. So in this way, we find that if we have taken 12 sides, the difference between the perimeter of the polygon and the circumference have become less. But if we similarly think of 24-sided polygon, then the difference between the circumference and the perimeter of this polygon will be still less. So as the number of sides of a regular polygon increases, the polygon being inscribed in the circle, as the number of sides of a regular polygon increases, the difference of its perimeter from the circumference also becomes smaller and smaller. So among these options, 24 is the correct answer. I hope this is clear.
Sir, yes.
Okay. So I am moving to the next problem. So sharing the screen. This is the problem. Second problem. P is the perimeter of a regular polygon of n sides inscribed in a circle with circumference C. C divided by P is closest to 1 among the options if n is equal to. Now C divided by P is closest to 1. What does it mean? If we say that C divided by P is very nearly equal to 1, then it means that C is very nearly equal to P. That means the circumference of the circle and the perimeter of the polygon are very nearly equal. So this you know from the previous case. If we make a sphere, as far as the two sides are concerned, even a polygon of two sides does not exist. So this is not possible. If we take the polygon of four sides, this is a sphere. Regular polygon of four sides is a sphere. See, the perimeter is less than the circumference clearly. But if we make each of these four arcs into two parts, then we have total 8 parts, and on joining by the straight edge, we get a regular polygon of 8 sides. Clearly, the perimeter of this polygon is greater than the perimeter of the sphere, but the perimeter of this polygon is still less than the circumference of the circle. So if we proceed, this was 8-sided polygon. Next we proceed to the last figure. In this we have made even 2 parts of each of the 8 arcs. So resulting into 16 parts. We have joined them with the straight edges. I can show this way. I have made this enlarged. You can see the green color straight edges. I have made 16-sided regular polygon. This is clear that the perimeter of this 16-sided polygon is more than the perimeter of 8-sided polygon, but still the perimeter of this 16-sided polygon is less than the circumference of the circle. Okay. So
Yes.
So it means circumference to the perimeter ratio is closest to 1 among these options if we have taken 16 sides, because 16 is here the highest possible number. So if this is clear, I am going to the next page. I am going to share this. This was the third problem in the quiz. P is the perimeter of a regular polygon of n sides inscribed in a circle with circumference C. If n be infinitely large, what will happen? I have copied the case this in which triangle had 3 sides, then double of that means we made a 6-sided polygon, then double of that means this is the case of n equal to 12. And here beginning with the square, that means 4 sides, double of that means we made an octagon, regular octagon, 8-sided polygon, then doubling that we have got a regular polygon of 16 sides. I am going to enlarge the picture and then you see yourself. In the first picture, yes, I was showing that in the first diagram, we begin with a triangle inside, 3-sided polygon, and doubled that number of sides, then we got a 6-sided regular polygon or regular hexagon. Then we doubled the number, we got a 12-sided regular polygon. So here the biggest possible regular polygon which has been drawn in the left side figure is 12-sided. In the second figure, we begin with the square, that is 4-sided regular polygon. Doubled it, so we got a regular polygon of 8 sides. That is called regular octagon. And then we doubled the sides, then we got 16 sides. So we have got this 16-sided regular polygon. If I enlarge the picture, you can yourself see that in the case of a 12-sided regular polygon, there is a gap visible between the green color side of this regular polygon of 12 sides and the circle, blue circle. But if you see the second figure where the number of sides of the polygon is 16, you find there is blue part of the circle is visible, green part of the regular polygon is visible, but no gap is seen there mostly. So that means if we have made a 12-sided regular polygon inside the circle, then no doubt the perimeter of the polygon is close to the circumference of the circle in length. But if we have made 16-sided regular polygon, then its perimeter has become closer to the circumference of the circle. I hope this much is clear.
Sir, yes.
Jasmeet, what you want to say, you have not understood what you are saying. In the chat box you have, is there any confusion now up to this point, or is it clear? Okay, then what is the problem? The problem is that if n be infinitely large, what will happen if we go on increasing the value of n? That means the regular polygon inscribed in the circle grows up in number of sides. The perimeter of the polygon will go on becoming closer and closer to the circumference of the circle. This is what I want to say. What will happen if n, when n becomes infinity? Infinity is written like this symbol. N becomes very, very, very large, that is infinite. Then the perimeter of the regular polygon becomes equal to the circumference of the circle. So therefore, C by P ratio becomes exactly equal to 1. So P by C is also exactly equal to 1. So that's why they become equal. It's not that C by P is greater than P by C or C by P is less than P by C. They become equal. So that's why the B option is correct. Is this clear? Jasmeet, I hope I have been able to make it clear now. Others, Daman,
Yes,
not understood?
understood.
Arpan,
Sir, understood.
Anmol,
Yes, sir.
Turkirat, Gurman, Man,
Sir, yes.
Mansirat,
Sir, yes.
Navraj, Sukhman.
Yes, sir.
Sir, yes.
Okay. So now I am going to the topic which I wanted to begin today. Now this thing has become clear that if we increase the number of sides of the regular polygon inscribed in the circle, then there is no difference between the regular polygon and the circle. They actually coincide with each other. So in the next part, we will see the use of this thing. Actually, next we are going to find the area of the circle, means the formula for the area of circle. I have taken in this figure 16 radii spaced at equal angles. Suppose radius is r, so each radius is r here. These are radii. I have placed these 16 radii at equal angles with respect to each other. If we join the end points of these radii, let me change the color this. Then I join next one like this and so on. But we are going to get, if we go on joining the end points, I need not join all. We will get a 16-sided regular polygon, 16-sided regular polygon. Why so? Because these angles are equal, radii are equal. What happens that by SAS congruence, these all triangles are congruent to each other. So by CPCT, these sides which are just drawn in red color, they are also equal. So when all the sides of a polygon inscribed in a circle are equal, then it is a regular polygon. It is a regular polygon. So we will get a 16-sided regular polygon. If we find the area of, if we want to find the area of this regular polygon, we can say this is equal to 16 times 16 times half into base. Base is, I am taking red color. Red color side I am taking as the base, into height. I am also going to draw the height. So this is the height here. This is the height. We can take half outside. Inside bracket we write 16 multiplied by base, multiply by height. Now this is the area of the polygon of 16 sides. If we take a regular polygon, for a regular polygon, of n sides for a regular polygon of n sides rather than 16, we will have n triangles. Then we will have the area of polygon given by n times half into base into height. Taking half outside in the bracket n times base multiply by height. I am simply representing the height as h. Now let us see what happens when n becomes very large, that is, it becomes infinitely large. Each base will coincide with r. How many bases will be there? N, because there are n triangles. If we have made a n sides regular polygon, there will be n triangles. So there will be n bases. Each base will be coinciding with the corresponding minor r in length. So what will happen? N times base. This will become the sum of all these arcs. Is this point clear? When n is becoming very large, n is becoming infinite, then the base of the triangle, red colored base, coincides with the arc, and there are n bases because there are n triangles. So n multiplied by base means adding all these bases which are n in number. That means adding all these n arcs. That means this will become the circumference of the circle, that is 2 pi r. Is this point clear? Yeah, Daman, Jasmeet, Anmol.
Yes, sir.
Those who are not able to understand, I can repeat this class also sometimes, whenever you will ask. So this 1 base, 2 base, 3 base, how many bases are there? N. Each base is becoming close to the arc, close to the arc. It is going to coincide with the arc in the length. So adding n bases means adding n arcs. N arcs are actually the n parts of the circle. So adding the n arcs means getting the circumference. So n times the base will become circumference of the circle. And this number half remains there. And what will happen to height? See, here in the 16-sided polygon as we have drawn, there is some gap between the side of the triangle and the arc. So this height is not exactly equal to the radius. But as this side will go closer to the arc, as this red side will go closer to the blue arc of the circle, the height will approach to the radius, height will become radius. Okay,
Sir, yes.
so area of the polygon becomes area of the circle. Area of circle which is equal to pi r square. Okay. So this is what I wanted to teach today. I hope this all is clear.
Sir, yes.
So I can close the class now. As I told you, Sunday there will be no class. So Monday we will be having class in the morning 11:30. Okay. So let me take the attendance and then I will leave. So, okay then.